Hello everyone. In this exercise of SolidWorks, we will understand the sheet metal basics. We'll, we will understand, we will see the two commands. Basically, one is the base flange and the and edge flange. This is the SolidWorks user interface. I am taking the plain white background and the unit system is the millimeter. Okay. For in for base flange, first we will have to make a sketch. Front plane, sketch. I take the center rectangle. I am taking this side as 80 mm. This side is taking the 120 mm. Okay, this one. I'm in the sheet metal. Sheet metal. This is the tabs. These are the tabs. If the sheet metal is there, if this tab is not coming, right click on this any tab. You right click tab and click the sheet metal. But my user interface, this tab is coming. Okay. In this way, you bring the sheet metal tab. In the sheet metal, you click the base flange. In this profile comes. This is the base flange. First, you will see T1 is the thickness of the plate. I am giving the 3 mm thickness, but reverse direction. Here, from here, you can change the direction. As per your drawing requirement, you can change. I am taking inside. Okay. A factor standard, that is the 0.5. Auto relief, we will discuss in the edge flange. There are three types of the relief: rectangular, tear, a brown. We will discuss when we apply the edge flange. Okay, this is the base. Now edge flange. Edge flange, I am clicking inside edge. You can click any edge, whether it's inside or outside. This one. Okay. If you use default option, default radius, you can change the radius. Basically, in this 3 mm radius is the inside band radius. This is the inside band radius, 3 mm. And 90-degree angle, this you can take any angle. Suppose I am taking 91, any angle you can set from here. 134, this one you can. This is the angle between this face and the flange. But I am taking 90-degree. Okay, this is the flange length. Now we will discuss this in detail. Flange length. Flange length, I am taking, for example, 40 mm. For example, but in the flange length there are the three options. This is outer virtual shaft. One by one we will discuss. First, I am taking the outer virtual shaft. I am taking top view. Outer virtual shaft means intersection point of outer edge. This outer edge and this flange outside. This is the intersection. The height is flange length is from this point to up to this end of this one. This is the outer virtual shaft. And this one, second one, inner edge. Inner virtual. This is the inner virtual shaft. If you hover on this option, you will see inner virtual shaft. It means height of the flange is from inside edge, intersection of inner edge and the inner edge of the flange, this edge flange. This intersection point height is taken from here. And this height, this option tangent band. If I take this thing, it means this height is from the tangent of the band up to the parallel end of the flange. This is height taken, but I am taking this from this point. And height of the flange is 40 mm, which is from the intersection point of outer edge and this outer edge of the flange, from here to here. This one. This is the flange length. Now the flange length position. Flange length position. Suppose this is the material inside. This is material inside. If I take this one, this is material outside. It means flange is shifted by thickness of the sheet. thickness I have taken 3 mm. So this flange shifted by 3 mm. Suppose I take this one, and it means the flange thickness, flange moves by 3 mm inner radius plus 3 mm sheet thickness. 6 mm moves here, and if only these are sufficient for this. Offset, if I take offset means offset I am giving 10 mm. It means this length increases by 10 mm. Offset is 10 mm plus 3 mm inner radius plus this one. So it means 16 mm is this from here to here. Or total length increases 120 length increases by 10 mm. This is the offset. I am taking this inside. I am taking this one. Offset I am not taking. This one. Okay. Relief I will take another flange. So this is the edge flange. If you should evaluate, if you check the radius will be this one, 3 mm. You can check radius is the 3. Sorry, inside radius. Inside radius. I am taking this one. This is 3 mm radius. Okay, and 3 mm radius plus 3 mm thickness. So this will be the 6 mm. You will see this is the thick 6 mm. Okay. And if you height you will take this height, this from this surface to this surface, height will be the 40 mm. You will see delta Z 40 mm. This height is from this one. This height is from the intersection of outer edge and this outer edge of this thing. Height is taken from this to the parallel end. In this way, this is the. Suppose you want to edit this flange, you can edit it here from here. You can add multiple flanges here. Suppose you want to add here, you can add here. Same thing. Outer virtual shaft. This is the outer virtual shaft, and this is the band outside. This band outside in this way. In this condition, the flange shifted by 3 plus 3, 6 mm. In this way, I am taking inside. This is the trick. You can take here also. This one. You can also take. Okay. If you want to change any flange, edit this one. You can select it. You can select here upper portion and edit flange. You can edit flange. You can here edit flange. Suppose I want to change this one. This. Suppose I am taking another flange. For example, edge flange. This time I am taking this one. Okay. Height is also I am taking 40 mm, for example. Okay. This is the outer virtual shaft up and metal inside this, and this is the metal inside. Okay. Metal inside. Custom relief. Custom relief you will discuss from here. This one. I am unchecking user relief ratio. Okay. User relief. Firstly, I will have to edit flanges. Edit flange. You can change the flange here. How you will change? This one, and this one. Smart dimension. Suppose this height is. Suppose this distance is 30 mm. This 40 mm. Height is from here 40 mm. This is fully defined. Back, back, and use relief ratio. You uncheck use relief ratio. This one. There are the three types of the ratio: oblong, rectangle, tear. Suppose I take rectangle. This means suppose I take width 2 mm and this is 1.5 mm. This is depth of the relief. This is the width of the relief. I take isometric view. You will see. This is the width. This portion. This is the width, and where the radius is start and band radius start. From here, this is the depth. I will show you. And get 2 mm and 1.5. Close it. Evaluate. Measure. You will see this is the width. This portion is known as the width. I am measuring. You will check this is 2 mm. Delete it. And again this I measure this one. This is 1.5. This is depth. Depth start from the where the bands ends. In this one. This is the 1.5. In this way, you can provide the relief. Again, if I edit it, if I take the oblong means the shape will be like this. The shape will be like this. I close it 2 mm. 2 mm is the width. This is the depth. 1.5 mm depth. This one. Okay. This is the oblong field. If I measure it, this, you will see 2 mm. 2 mm is the this one. Delete. If I measure this thing, this is 1.5. This is the depth. Depth is starts from the where the band ends, and from this point to this point. This is the this one. In this way, the relief is provided. Okay. If again I change it, another relief is a tear. Tear means gap. Tear means this one. There is no gap between here. In this way, and again edit. You can edit from here. Edit. I am again taking the oblong. This way you can provide the relief ratio. If suppose use relief ratio, if use this one, 0.5 means 0.5 into sheet thickness. Sheet thickness is 3 mm. It means half of the thickness. 0.5 into 3, that will be equal to 1.5. So this will be 1.5 will be the width and 1.5 will be the depth. Suppose I give 0.5 ratio, this one. It means if you measure it, this one, this is 1.5. Okay. And if I take this distance, and this distance, this is the 1.5 in this way. If you want to change the, suppose for example, you change the thickness ratio 1 mm, you take, suppose 1 mm. 1 mm means 1 into 3 sheet thickness, so the 3 mm. And the width will be 3 and the depth will be 3. If I check it, this one increases. Measure one. This is 3 mm. Right click, clear. If I check distance between this is the width. This is the 3 mm. This is delta by 3 mm. In this way, we can apply the auto relief. If you want to change the suppose you want to edit this feature here, base flange, from the base flange you can change the edit feature. From here you can change size of the base flange 80 mm. This one here we can change. You can also change the thickness of the sheet, override by clicking this one. This way you can change this one. Okay. Sheet you can edit from here. Here also sheet you can 3 mm radius you can change here. In this way you can apply the right click. Suppose I edit this first flange. Right click, edit. You can add more flange here. This one. This one. Inner radius is 3 mm. Gap is 9 mm. This gap is the between this gap between two flanges. 9 mm. Suppose I am taking 2 mm. This gap is, you will see this gap is between this or this flange. 2 mm. 3 mm is the inner radius. 3 mm is the inner radius. This one. And this is the outer virtuous shaft. Outer virtuous shaft. This height is from outer edge to the up to this side. And this is the metal inside. Outside. This is bend outside. In this way you can take the position. Custom relief I have also told you. In this way you can provide the edge flange in the sheet metal. I hope you would have enjoyed in my this exercise. You please subscribe my this channel and like and share. Thanks for watching. Thanks for watching. Okay.